Hello everyone, welcome back to Science Free. Today we're gonna do a tutorial on how to solve pairs of simultaneous equations by the method of substitution. The first thing to do is to observe both equations and check which of them contains a single coefficient. Equation 1 contains a single coefficient of just y. And in equation 2, it contains a coefficient of 3y, which means the 3 is multiplying by a y. So that means we need to make the subject for equation 1 equal y. Because the y is negative, we want to move it to the right behind the equal sign, and it will become a positive y. We also need to move over positive 5 to the left, and it will become a minus 5. As I stated earlier, 3 is multiplying by y in equation 2, and y is equal to 2x minus 5, we need to replace y with 2x minus 5. And allow the equation to equal back 4. We can now go ahead and use the distributive law to clear the brackets. 3 times 2x equals 6x. 3 times minus 5 gives minus 15. We make the equation equal back 4. We have to look for like terms now. 4x and 6x are like terms, so we can add them. 4x plus 6x equals 10x. And now we want to transpose to find x, so we move over 15 to the right behind 4 after the equal sign. And it will become a positive 15. 15 plus 4 equals 19. To get x alone now we divide both sides by 10. 10 divided into 10 cancel out leaving only 1x. It's better to keep the fraction on the right as 19 over 10 because we will get decimals if we try to divide. So since we found the value for x, we need to find the value for y. So we have to substitute the value for x in equation 1. And we write back minus 5 equals y. We can work out the fraction. 10 can be cross-divided into 2, so we divided 2 into itself, the result is 1. 10 divided into 2 equals 5. 1 times 19 gives 19. 1 times 5 gives 5. So we are left with 19 over 5. We now have to minus 5. The LCM is 5. 5 divided into 5 equals 1. 1 times 19 gives 19. We carry down the minus sign. 5 divided into 1 gives 5. 5 times 5 equals 25. 19 from 25 equals minus 6. We write 5 below 6. And now we have found both the missing values for x and y, we can now move along to example 2. For this example, we take similar steps. We again need to look in both equations to see which has a single coefficient. Equation 2 has a single coefficient of x. We need to make it the subject. We do that by moving over the positive 3y to the right behind 2, and it will become a minus 3y. Since we get x to equal 2 minus 3y, we look for x in equation 1 and replace x with 2 minus 3y. And we now write minus 5y equals minus 6. We want to now clear the brackets. 3 times 2 equals 6. 3 times minus 3y equals minus 9y. We write back behind minus 5y equals minus 6. Minus 9y minus 5y are like terms. Minus 9y minus 5y equals minus 14y. We write back the equal sign and a minus 6. We want to get 14y on one side, so we move over 6 on the left to the right behind the minus 6 after the equal sign, and it will become a minus 6. Minus 6 equals minus 12. To get y by itself, we divide both sides by minus 14. Dividing minus 14 into minus 14, they will cancel leaving y. On the right we have minus 12 divided into minus 14, the minus sign will cancel whenever dividing two negative numbers. Both 12 and 14 could be reduced. The largest number that could go into both 12 and 14 is 2. 12 divided into 2 gives 6. 14 divided into 2 gives 7. We can now go ahead and substitute the value we have for y in equation 1 to find x. Doing the multiplication side first. We do 3 times 6 equal 18 and 1 times 7 equals 7. Two minus 7 over 18 equals minus 4 over 7. So the value for x is minus 4 over 7 and the value for y is 6 over 7. Thank you for watching. If you have any questions, you could leave them in the comments section or you could send us an email through our email provided in the description. And if you haven't, you can subscribe to our channel if you don't want to miss out on our weekly tutorials.